All right. So now that we cover some of the admin stuff that we mentioned, and you should now see that this is in recording. These from this point on will be posted on YouTube. And I'll send a link to everyone basically on the class announcement. You can check it out and feel free to have, if you have any questions while you are listening to the YouTube recording, feel free to ask me that too. And feel free to like make it faster. Uh, if you have questions, feel free to use the private chat. I forgot to say that. Basically, WebEx allows you to privately ask me things. Uh, a lot of you have done this in system skill class or the file processing class, which is the same class but different name. Uh, and I find it really helpful when some of you are like falling behind, right? That's the only way I can tell whether you're with me or not, because none of you have the video open. I can't see your face. I can see you nodding your head. I can't see whether you're actually looking at the screen or just doing something else on a different screen, right? So this is I know. I was a student before. It's just like this is human nature, right? And especially with 4 hours lecture, it's not like I don't understand. I cannot listen to lecture for 4 hours. Oh, hi. So yeah, so I know that 4 hours lecture is tough. I have to be saying again, like, sorry about having this slot. This is the only slot that works for me so that I can teach 2 classes this semester. Uh, and these are the 3 languages that we're going to focus on, mainly the first 2. Scala, which would be cover and used for functional programming, which is the first part of the content. Once you know how you can come up with the program, the language itself, right? Scala would then we will shift from Scala to Rust. From Rust is like a language that's designed to support parallel programming really well. The reason why I said really well is it's really safe and you ended up with a lot less bugs than using C++. But then you're gonna run into a lot of compilation error. There are trade-offs over there. Feel free to let me know when you run into any of those things so that we can go through them together in office hour or like afterward. And then we'll use C++ for some examples in OpenMP. How many of you heard about OpenMP? OpenMP. Basically, this is one of the, I guess, library that you can use in C++ that say, hey, if I have this for loop, if I have the for loop block, you basically tell the program, hey, do this in parallel. And OpenMP magically, not magically, that's that theory behind it, but basically they'll take the for loop. Every time you go through the loop, each iteration is actually done in parallel. So let's say you have for I equals 0, I less than and I plus plus, right? When I is 0, it's actually get run. At the same time as when I is 1, when I is 2, when I is 3. So that way you can imagine this is gonna make your program faster, right? Because you do more iteration per unit of time. We will talk about how can we make that happen and what can prevent the performance gain that you are expecting to see. What can become the bottleneck? What can make things slow when you use OpenMP or Rust? There'll be both lecture slides and coding exercise. I promise you lecture would not exceed 3 hours most of the time. Most of the time I'm gonna aim it toward 1.5 hour to 2 hours, right? Between that. And then there'll be a longer break. I know it's going through lunchtime, right? I'm human. I am actually a rather large human, so I know hunger can distract you. Uh, Without joking too much about that. But yeah, you have a longer break in the middle. I would likely come back. Basically, I'm gonna allow you to like go get lunch, come back to class and eat while you're doing exercise, that's fine. If you want to eat first and do the exercise later, that's also fine, right? The point here is learning. Whatever makes you learn well is fine. And yeah, feel free to eat during class. I don't care. Then you do an in-class exercise. We will switch depending on how it works. There's a high chance I'm gonna basically switch to Discord because it allow you to kind of like talk at the same time, and someone share the screen, someone else can see the screen, and you can even like have a bunch of like parallel live sessions. So I can switch between each live session. So I think yes, we have Discord voice channel. That's a great question. I already created a Discord voice channel for this class. And here's my expectation. There'll be a lot of new way of coding, so be prepared to learn new language. And it feels different. Let me use my experience. The first time I learned functional programming, when I was at CMU, I think actually we won by Ajahn Kanat because he was like my senior, right? and it's kind of like functional programming will feel different because it's based on maths, right? It doesn't based on what you learn how to program from day one, which is like, okay, you write this code, it will go line by line. It doesn't go line by line anymore. Everything is a function. So I took the class, and even with warning, it still surprised me. It's not hard; it's just different way of thinking. And then this applies to both the assignment and the projects. And then workload in this class, because it's a new language, so it tends to be heavy because you need to learn like, okay, if I want to do this, how to write the code so that it does whatever I want it to do. So my advice is start the assignment early. At minimum, please, at least, right? At least read the assignment so you in your brain can figure out, okay, for this task I would need these many hours, so you don't panic the day before the assignment is due. I was a student before. I know how this worked. Despite all my warning, you just worked on this on the last day. Trust me, I know. But I need to give the warning. And for this class, you should have a good grasp of Python, Java, and you should know some basic on computer systems. You don't have to take the OS to like take this class. I'll cover the background that you need to know. There's not a lot of system related things, so it's good to know like, okay, this is how computer works. If you took computer architecture before, I think many of the 60 and 50, like I think 60 student, right? I think they take ComArch before. Hopefully you can translate some of that content to here and see how you can get performance. But if you're curious about that, you can ask me. I'm one of the ComArch expert in Asia. So if you have any questions related to hardware, let me know. So the last bullet point, if you have any questions about anything, let me know. This is like my comfort zone. Oh, you haven't taken this system skill branch? Nah, that's okay. It's a lot more about how you work with math function, how you work with the language that you're learning. And when you go to parallel programming, I'll explain it to you in detail. Some of the things that can make your program slow, even though you write it in a way that you're supposed to be able to parallelize them, making them like, for example, right? You want these two tasks of the program to run in parallel, but somehow they ended up running, one of them is running. If you know system, if you know the hardware, you can tell, okay, this might be something that goes wrong. I'll teach you that. The way I structure this class is hopefully you don't need prior background too much as long as you're a competent programmer to some extent, like in the way that you are like sophomore or junior CS degree, you should be fine. That's how we structure this class. If you're worried, let me know. Basically, I am open to like, hey, you have any worry? Just let me know. I'll make sure I address all the things that you have. So what will you learn in this class? By the way, do you actually hear the background noise about like a cat collar, like and cats walking around? I'm sorry about that. Yeah, my wife arrived from the US last night, so our cat has to be here while she's getting quarantine. Oh, show me my cat. Yeah, sure. Honey. All right, yeah, here's my cat. Oh, she's heavy. So yeah, here's my cat, which is now gone. So Numnim, her name is Numnim, and I have another cat name is Namtan. So yeah, if this is distracting, let me know. But if this help you wake, like being awake, because sometimes they'll go play at the cat condo behind me, I'll keep them around. So I have a separate room. I can keep the cat in that room too. While we basically my wife is getting quarantine. Your choice. Uh, basically because they were walking around and they're making noises. So if it's too noisy, let me know. I can put them into another room and they'll play in that room while I'm teaching. Okay, you want to keep the cat? Sure, yeah. I would be happy to keep the cats in the room while I'm teaching. I think they are nice enough to not jump on my keyboard. I'm hoping they did last night. So yeah, we'll see. Okay, so yeah, GitHub cat. So yeah, so what are you learning in this class? The goal here, this is the goal of what we want to learn here. That's worth waking up at 10. Okay. So you just want to see the cat, you don't want to listen to the lecture. Awesome. So you should be able to know some essential concepts of programming language. Why do you Hey, context switch from cats to lecture. Come back. The cat will be around. I'm guarantee you. Sometimes they're just gonna walk around. Um, what you want to learn from this class is you would then know why some language is designed in certain way. What are the main things that they have to offer as to the programmer, basically as a language? What are the common things that you need to know across different language? You see a lot of common occurrence from Java to Python to C. What else? What other? Actually, let me ask you a question. Besides Python, Java, and C, have you tried any other languages that are around?
MATLAB.
MATLAB. Okay. C sharp. Okay, awesome. Actually, I did C sharp and MATLAB. Haskell. Okay, awesome. You did Haskell before. So if you try Haskell before, you're gonna do well in this class because the way the program is the same. It's Haskell is also a functional language. JS, JavaScript. JavaScript is okay. LaTeX is not. LaTeX is a tool. uh, Wait. Okay. TypeScript. Okay. So the scripting language is a little bit different. I would put MATLAB in the same category as that as well. Basically, they have a lot of APIs, a lot of library, and then you call a lot of those API and library rather than you build your own functions. Uh, MATLAB is kind of like in the weird point between the language and not the language. If you look at the debate from a theoretical point of view, yeah, MATLAB is making things easy, but they charge you a lot of money. Actually, if you want to get that license, it's so expensive. Yes, but even at CMU, like if you work on something related to MATLAB and you want to use it as a product, then you're screwed. You need to pay them. Right? So you if you have something implemented in MATLAB and you want to launch your own startup, Yeah. So the school would have it, right? But let's say you build something using the school license and you want to like spin it off to a startup. Now you have to figure out whether how you're gonna pay for that, or if you need to write your own script or APIs or something. That's why sometimes Python is a little bit cheaper alternative, which can offer the same performance or better sometimes. Uh, Yeah. So the second thing I want you to know is what's the benefit of parallel programming? And I'm gonna keep feeding you that it's gonna make your program fast, right? And I think Thailand, this is my personal opinion, right? Thailand is in a position that they haven't realized that once you need to scale the number of user, let's say you have an app, right? Let's say you develop some apps or develop some software tools for the user to use, when you have to scale them from hundreds of users to 100 millions of users, where you actually would then get paid a lot for the work you've done, right? Parallel programming comes into play. You want the performance because you can't scale. That's why knowing things like computer system, the content of this class, parallel programming, computer architecture, that's where we comes in and was like attack the problem, right? Uh, so the last thing I want you to know is given an algorithm, then most of the algorithm you learned so far is called sequential program, right? It's not parallel. You do things one at a time. How can you make it such that you can increase parallelism? Yay, right? So you can well, not magically, but get more performance. So now we're gonna move on, right? Move on to how we design a programming language. Before we move on, any questions that you want to ask? I know that I'm talking slowly. I want to make sure everyone is with me. But if I start losing you because I'm too slow, let me know. I can talk a lot faster too, depending on your pace. So if you want to secretly hinting me that hey, can you go faster? Let me know. That's the first thing. Any other questions? No. Yes. Okay. So I assume there's no more questions about the thing we covered so far. So design. So let's talk about programming language, right? And that design trade-off. How many of you heard about the word syntax? Awesome. Syntax error. Yes. How about semantic? I'll explain the two together because I think they are linked in some form, basically. I'm gonna compare this against English language, right? You know that in English, there's grammar, right? Where you have things like subject-verb agreements. How do you use articles? Right? How would you use the future tense versus the present tense versus the past tense, right? These are syntax. Syntax means that I'm going to structure my sentence in a way that's correct based on the guideline, based on the rule. Semantics is, let's say you string together a lot of sentences in English. What do they mean in that paragraph? Right? What does a paragraph mean? So if you compare to English, then I'm gonna write it over here. This is kind of like the grammar. And this is like what does the paragraph mean? And if my handwriting is getting way too bad, let me know because I know my handwriting is not readable in many cases. So semantic is telling you what does the writer wants you to know. The same thing goes with program, right? If you look at the code, look at your program, Semantic information tells you, okay, this program is trying to do this and that and that and that. Syntax means you write it correctly or not. Did you forget things like semicolon? Did you forget to close the parentheses? Any questions about the two? Are those clear? So whenever they complain about syntax error, it means like the compiler, when you compile the code, they say, hey, I don't know what you're trying to do here because I don't have the rule about what to do given this line, right? Given this line. Semantic information is when you write everything correctly, right? You can string together a sentence in English that totally has zero meaning, right? Totally have zero meaning. That's possible. It would compile in the program, and when you run it, you get random weird results, right? So think about it this way: a good program should have both syntactically be correct, right? And then it should have some semantic information. When you have a programming language, syntax, some of them can be more complex, right? How many of you hate C compared to Java or Python? Come on, don't hide that fact. I think a lot of you hate that. C is hard, right? So how many of you hate assembly even more? Yep. So the complexity of the code. Okay, so if you haven't tried, how about between Java and Python? Right? Python is going to be easier to write than Java. Basically, there's this complexity of your. Oh, Java is easier. Okay, interesting. But I can see that too, actually. Depending on what you want to do on Python, and if C grew on you, congrats, you are getting super nerdy. But that's a good thing. That's a good thing. C is pretty powerful when you want to get performance, right? So if that grew on me, I would definitely recommend you to look into things like system programming and parallel programming and things that related to getting performance and or designing a system. Uh, Paradigm that the language favor, right? What functional language, for example, would favor the paradigm we call Dataflow. We're going to talk about what Dataflow is today. C, Java, and Python would follow what we call von Neumann paradigm. Von Neumann is basically a code happen. The first line would get run, followed by the second line in your code, followed by the third line in your code, followed by the fourth line in your code. So different language favor different paradigm, and different paradigm give you different performance versus programmability. What is programmability? Anyone want to take a guess what programmability means? It's programmable, right? So how easy it is to program. Python is pretty programmable. It's just Python and Java, right? Compared to assembly, you can now see the difference. The type system and the type group, we'll talk about this in detail in this class. So we will skip this bullet point for now. There are about 2 lectures, or actually 1 lecture because it's 4 hours now. 1 lecture worth of content about type system. Memory management, if you look at C code, if you program in C before, you would then notice that you have to manage the memory pretty manually versus Java or Python, where you don't have to worry about things that you use. In Python, if you use an array, right, the array will magically appear. Yay. And you can use list in Python. It will magically appear. You can magically put things into the list and it would grow. In C, you need to manage how this list grow, right? So different language would favor different memory management. Some languages doesn't even need a compiler like Python, right? Python would interpret your code and know what you should do. C, Java needs a compiler. You need to compile. The compiler will look at your code, optimize your code automatically. It's like magically it's a black box that you put in codes. They will spit out the optimized assembly code based on your program. Hopefully that's faster, and then you can run it. All right, and programming language kind of change over time. So I'm gonna dive into more like a historical context of when things gets developed. This won't go onto the exam. This is just for your information, not necessary to learn programming language, but I just want to tell you the history. The early day of programming language is around like 1950, right? And the key things here is back in the day, hardware is expensive, labor is cheap. Why do I say that? To build the machine, how many of you seen Imitation Game with Benedict Cumberbatch? Yeah. So if you've seen the movie, right, they're building this computer, which that's actually one of the very first computer that get built in the world, right? And you notice how costly it is and how big it is, right? It's super big, super costly. So if you compare that to a salary of a scientist, like all the actors in there, right, it's cheaper. So early days programming would try to minimize what the computer has to do, right? That's why I say it mirror hardware concepts. The goal is you can't really write a program. The compiler is a program. Compiler read your code, optimize your code to make it faster. Back in the day, you can't do that. The computer is not that powerful. So compiler optimization is something you can't do, period. It's too costly. Human is cheaper. We are cheaper back in the day, right? Parts are costly. Program has to be efficient from the get-go. So the programmer, the scientist, has to optimize code by hand. They have to optimize code by hand. These change quite a lot. Any one of you want to make a guess on what's my impression of the average salary of a bachelor degree student who got an undergraduate who worked in Silicon Valley in one of the FANG companies, Facebook, Apple, Google, and uh, uh, what's that? Netflix, yes. So anyone want to take a guess? What's their yearly salary? The figure that I've heard, yes, around 100K. That's pretty expensive, right? So that you got it right. It's about 100K yearly. Or you need to pay a lot of rent if you're in the Silicon Valley. So that gets. I'm joking about the housing situation in California. So if you get a master degree or PhD, that figure get bumped to like 150, like 120K, 150K for the master, and then close to 200K for the PhD, right? So now what happened is our salary is costing a lot. $100,000. How many computer, how many desktop can you buy? You can buy like 100, probably 100 really good desktop, right? So now computer gets a lot more powerful. So when you design a language, right, it now center on design concepts, things like having objects, having different kind of function, having library, having a lot of libraries that you can do and call, right? So machine is actually getting cheaper too. Like according to Moore's law, we double the transistor every couple of years. We get really powerful machine these days. My phone is more powerful than my desktop 20 years, 15 years ago. I'm not that old. Desktop 15 years ago when I was a high school student. Uh, so machine is a lot cheaper. So in efficient code or using scripting are kind of okay. I have a lot of question mark here, but it's kind of okay. You want to quickly develop your program, right? And now, what you are trying to develop, when you're trying to develop a program, you look at the design goal, right? And look at the resource constraint. What is the expensive part, such as is it power in mobile phone? Do you want to get a lot of performance in a computing cluster or supercomputer, right? Then you write the program based on that. And why are there so many languages? Why there are so many languages? Basically, the reason is because there are trade-offs, right? There are ease of use, right? There is debate among you it's between Python and Java, but both are easy to use. That's why when you go into a CS degree, the first thing they're teaching you is either Python or Java, right? Safety, we'll talk about this when we cover Rust. Some languages are more safe than other. Python is less likely to have memory related errors. So if you took system skill, for those of you who take system skill with me, how many of you are so sick of segmentation fault? I think I asked this question like 3 times already. At this this is something that's been haunting you forever. Even now, I still hate it when my code throw out segmentation fault. Rust, for example, would take care of this when you compile. So each language offer different things. C, despite the safety issues, you get performance. It's really fast. So if you want to write fast code, use C or C++, etc., etc. Okay, let's briefly discuss that. What do you heard it from? So Rust would make it so hard to compile, but once it's compiled, it's safe. It's kind of like instead of giving you segmentation fault, which just one line with no additional messages of what's going on and why it's seg fault, Rust would compile, analyze your code, and tell you what caused the potential seg fault. How do you debug on Rust? The compiler would tell you what goes wrong. It's not actually. If you look at the message, so how many of you, when you compile your code, look at the error message or warning? Oh, definitely you can pray, right? But how many of you, when you compile the code, you look at the error message? It would tell you something, right? It would tell you something. Rust would tell you what can go wrong. Sometimes you would like, what does this mean? And then you go to Stack Overflow, right? And at least between that and segmentation fault, you can still copy the error message, put that on Stack Overflow, right? Okay, you only learn how to read it at the end of OOP. Well, now you know, right? This error message is meaningful in some sense. The minimum you can do is copy the message, put it on Stack Overflow, copy the message, put it on Discord, and yell out loud, tag at me, at my name, so that I can take a look at what's wrong here. It's better than segfault, to be honest, right? Segfault just give you that one line without anything else, and you have to kind of use the GDB to dig deeper and like what's going on, what goes wrong here, right? Don't trust me. I'm not. I don't. Let me put it this way. Every human being can make errors, right? I'm confident in certain things, right? I'm expert in things like computer architecture. I'm expert in designing the hardware, but I don't know everything. So don't always trust me. I can say wrong thing. So that's something I really want you out, right? That hey, if I don't know something, I'll tell you I don't know. I'm gonna try to look it up, and we'll figure this out together, right? We'll need to figure these things that I don't know out together, right? I think that's we have to be honest, right? I don't know every single thing. Uh, all right, and now we're gonna cover the rest of the first half of this class. So now that we talk about the language a little bit, right, and what constitutes a language, I want to move on to like the second half of the class to motivate you on what we're gonna learn, right? There's the emergence of parallelisms. This is a common way you write a program. We call this von Neumann model. Why do we call it von Neumann model? The reason is because this is a name, right? Von Neumann. He came up with the machine back in the day. I think it's 1950 or 1950, probably 50. And then the machine used this model to store a program, to run a program, to write the program. And we still use it nowadays in C, Java, Python, all the iterative programming. They follow the von Neumann model. Look at how old it is, 70 years, right? That's how much impact this guy is making. And this is how it is done. This is called a store program computer, which means, okay, quotation emergence, yeah. It means that it doesn't mean much to you right now. What it really means is this. Your program that you write, when you're running it, the whole program get copy from the hard drive from your computer to the DRAM, the memory that you buy, right? That is where you interface with the CPU. Memory is the only interface with the CPU. The CPU that you buy, the Core i7, i5, they talk to the memory. The way you run the program get copied over from this hard drive, right? They get copied over to the memory. And both the instruction, which is the program, right? This is the program. And the data, right? Let's say you have you process a graph, so the graph data would be inside the memory as well. You have one big memory. When you buy DRAM, put it on your computer, that's one big memory, right? One single thing. And the computer will kind of like put different control signal. Control signal means it's gonna tell these parts to do this thing. You're gonna tell DRAM to read the data for the CPU. I'm gonna tell the adder to add the two numbers together. I'm gonna tell the code that handle the if else, right, to evaluate if this is true. If this is true, do this part of your code. If this is false, do the other part of your code. And this is called sequential instruction processing. Highlight is on the word sequential, right? Oh, no, not here, I say. Right, it's sequential, which means that you run one instruction at a time. Instruction is your assembly code, each line in your assembly code. That's an instruction. This model run one instruction at a time. So if you look at your program C, right? What is the first function C would run? All right, File Pro folks and System Skill folk, what's the first function that C run? It main, right? You start at the main function, then the first line in the main function, the second line, the third line, the fourth line. This is von Neumann model. Any questions about the von Neumann model? Basically, you run it line by line by line. Sometimes we call this iterative programming. Why? Because we iterate from the first line to the second line, to the third line, fourth line, to the fifth line. Except when you have for loop and if. And here's the example. Here's one discussion. Is this the only model? In this class, you then realize, nope. But this is one of the most dominant because it's easy to think about, right? For serial programming, yes, yeah. So the reason why it's most dominant is all ISA. The ISA is the what defined at your assembly code, right? x86 is what you learn in file processing. MIPS is what I'm forcing you to do in the lab in ComArt this semester. Hopefully that's interesting. ARM is what you would see in your iPhone, right? Your I think probably also like things like Nintendo Switch, we for sure use ARM. Spark and Power are in the Apple SoC. When they said SoC means system on chip. So let me iterate over your comments because I find that interesting. I'm gonna go sidetrack here, and I tend to go sidetrack a lot. If I go sidetrack too much, let me know. That's one of the complaints I got from all the class I'm, I'm teaching. I love to go sidetrack. When I see interesting things get discussed. SoC stand for System on Chip. Right? What does System on Chip mean? It means that in the chip, you have something like oops, not highlighter. Right? So SoC is something like this. Let's say you have a CPU. You have also a GPU on the same chip. You can then have these things like in Apple, SoC, for example, they have a security chip, right? You can have the camera, right? Camera accelerator. Basically, it's a piece of hardware that process whatever you're trying to take picture. And these days also this thing called neural processor that work with machine learning program, right? In the Apple SoC, that's a chip specifically designed to process, I would say, matrix multiply. It's designed to process matrix multiply. Why do you want to design a chip that just do matrix multiply? Machine learning is all about matrix multiply. Right? So if you throw a bunch of matrix multiply on that chip, it's going to be super fast. So this is why what SoC means. It's a chip that consists of full-blown system that can process normal program on the CPU, graphics on GPU, many more things like modem, right? You might have even a modem chip here, MODM, right? That process the 4G signal, which can now be 5G in some phone, right? You have a security chip where it store all your fingerprints. Actually, it doesn't. I think Apple doesn't store it on the security. Actually, I'm not sure because I haven't seen their white paper. I need to keep waiting for what they're gonna tell us. But basically, it would handle all your fingerprint ID, your face ID, and make sure that even the iOS cannot access it. Even the iOS. These security chip isolate your information without trusting anyone. The design is done in a way that I cannot trust even the iOS. That way you can protect your information. Right? It's a big topic in architecture actually, how you would design this kind of chip because this thing is super slow. It's really slow when you have to make that assumption. So how can you make it fast? How can you make it small? It's a big problem. So is it impossible to hack? As far as I am aware, which might be wrong, which might be wrong. Most hacking happen when someone doesn't follow a guideline. That's as far as I'm aware. There's a talk about hacking. Actually, it's more about like frauding. How many of you listen to like watch Catch Me If You Can? So there's a talk by that guy, that real person who the movie portrayed. He was giving a talk at Google, and because after at the conclusion of the movie, you realize right he actually worked with the FBI in the fraud department. He was looking at like check fraud, follow up. He actually moved on to like security. And one thing he says like I think I might quote it wrong, but basically the gist of it is if you look at most of the hacking that are done nowadays, it's almost always some engineer forget to follow some guideline. That's when hacking happen. Jailbreak is more like if you have the design of the OS, or if you can somehow hack into some of the OS code, you can jailbreak because you can kind of destroy some of the protection, right? And rewrite some of the iOS code that responsible for things like what apps can be installed. Will I check if it have to come from an app store? So you can write your own installation and jailbreak, right? And I totally do not recommend you do that nowadays. Why is that the case? Because you're then not supported by some of the security features that iOS is designed to support. And you're trusting some random programmer who write this software to do the jailbreak. You're trusting them your own kernel code, right? Your own kernel code, which means he or she can do everything on your phone. And this is actually why the security chip is important, because then in that case, I cannot even trust the iOS because you just jailbroken your phone, right? All right, I'm super sidetracked right now. So hopefully you have fun with the discussion. Let's move back to the class. So what's the alternative with one Neumann model? Okay, let's come back to one Neumann model. Is iterative programming run line by line by line by line. The alternate model, which it will be the main focus of the class, is called the Dataflow model. What is the Dataflow model? Instead of run things in control flow order, control flow means I'm going to run first line, second line, third line. If there's a if else, you would look at, do I go to the if or do I go to the else? You follow Dataflow, right? If you follow the Dataflow model means that I don't care about the order of what I write when. If I look at everything as a function, what does a function consist of, right? Let's say you have f of n equal something, something, something. When can I run this function? When can I run this function? Let me ask you this question. When can I run f of n? It's when you know what is the value of n, right? Once you know what's the value of n, when data is ready, you can run it. So let's say you write a program this way. You have g of n, f of m, and h of, I guess, p, right? And somehow, this is like line by line by line. In the control flow order, you would then run g of n, followed by f of m, followed by h of p, right? This is control flow order. In the data flow order, is they'll look at these three functions. Do I have n? Do I have m? Do I have p? And let's say I have p first. Magically, I don't know, p appear first. And let's say it's 5. You would then first run h of 5 because you have everything ready to run h. Then you then look and, okay, where's n and where's m? Once you have m, for example, you run f of m, followed by whenever you have n, then you run g of n. Any question about the data flow order? Basically, it compute when the operands, right? The operands means that whatever goes into your function as an input, whenever that becomes ready, you run without any regard of like, okay, this is like the last line in your code. Well, you have it. You have all the data, just run it. Who cares, right? There's no, if you look at the hardware, there's no instruction pointer. This is more hardware related. You don't have to remember this. Just remember that you run the function whenever you have all the inputs. When the input is ready, your function is ready to run. That's it. Think of it as a math function, right? A math function. If you know the inputs, you can compute, you can evaluate the function. That's all. And these allow many instructions or many functions to be executed or run at the same time, right? This enable parallelism. And here's a comparison. Here's a sequential program. This is what I want to do. I first add A and B, write that result to C, and then multiply B by 10, put that into X, add B with X, put that into Y, and then C plus Y is D, the Z, right? In Dataflow order, in control flow, this would, let's say each line take 1 unit of time. Let's say they take 1 second, right? This thing would take in total 4 seconds, right? 4 seconds because you do first line, followed by second line, followed by third line, followed by fourth line. In Dataflow order, the first thing that you see is like, okay, the first line here and the second line here can be done in parallel, right? When you know the value of B, for example, you can do the multiply. And when you know the value of A, you can do the add. So you can do this in parallel. And then the next cycle, the next 1 second, you can do the add y equal B plus X. Then wait for the data for Y, right? Then you can do C equals C plus Y, which means that this is 1 second, 1 second, and 1 second. You notice how now we do one of the line in parallel, right? The add and then multiply. This is 1 second, 1 second, 1 second, and 1 second. So this is 4 seconds. This is 3 seconds. And you can imagine if you can do this way in parallel, let's say that one line consists of 10 different things. 10 different things. It means that you can somehow hopefully get 10x faster in Dataflow model, right? But let me ask this question, which one of these is more natural as a programmer? The first one or the second one, sequential or Dataflow? Anyone who's still with me, can you type in something? The first one, yes. At least for me. I think it depends, actually. It's subjective. It's pretty subjective because I have heard a bunch of people who has a lot more like math background, they would like the second one. But we are so trained to do the first one, right? We are so trained to do the first one. C is done using the sequential model. Java, Python is so done using sequential model. So we kind of train toward the first one. These days, the way you design the CPU, it allows you to write the first type, the sequential type, but it would try to run your code in the second type. So it kind of get the best of both worlds. And let me talk about some type of data flow node a little bit before we go to one of the example. I'm going to show you how you can write a data flow model. You can have things like compute node, relational, like you have A and B inputs, right? You compare A and B, it produces either true or false, which then can be fed into another node like this, right? You connect them together. You have a branch. If this is true, then basically if this is true, send X to here. If this is false, send X to here, right? And you can have synchronization. When you do things in parallel, at the end of the day, you need to like combine all the results together. That's what the barrier is for. And here's first, I guess, in class group exercise. While we're taking a quick break, you don't have to submit this. This is not the actual in class exercise. I just want to give you an example of what can be done using the data flow model. And to be honest, I would just have you focus on the left side of this. What does it do? The right side is doing a different thing. You are doing both left and right side at the same time. What does this program do? We'll take a quick break. Maybe we'll be back in about 20 minutes. Feel free to stare at this a little bit. Once I'm back, I'm gonna tell you what this thing actually do. All right, so we'll meet back again at let's say 11. It's 4 hours slot, so we have a lot of time. Let's do a 15 minutes break. All right, let's do a 15-minute break. We'll meet at 11:25. Is that okay? All right. Yeah, go take a break, go get coffee, drinks, I don't know, soda, whatever can make you make you more conscious. Yeah, 11:25. Let's just meet at 11:25. Uh, I know it's a long lecture. I'm trying my best to like make sure I time it so that you have time to take a break, and also time to like say type something and like make it more interactive rather than me monologuing all the time. All right. So I'll stop my webcam for like 3 minutes, 4 minutes, and I'll be right back. If anyone have any questions, once I'm back, feel free to ask me. All right, I'm back. If you have any questions, feel free to ask anything. All right, for some of you who are back, welcome back. Any question? We are taking a break. We can have a casual chat too. I mean, whatever to make you awake, because I know that some of you might have class after this as well. All right, so let's come back. It's 11:25. So if you look at this part of the Dataflow model, pen, please. Well, I can't draw. Let me. This is counting, right? It's counting starting from 0, and whenever this thing is true, you count up. And these basically would do A, X, or B and keep counting down in a loop. Which basically means that if you compare A to B in binary, how many flips between 1 and 0 would you have to do to make A equals to B? And we call this Hamming distance. It has a lot of use in security. It can tell you whether the thing you're looking at is getting tampered or not. And as you can see, the left and the right side are all done in parallel, right? You do the left side, you do the right side, both at the same time. That's possible, right? With the Dataflow model. All right, so I think there was some noise here, so let me. I can't wait. All right, so any lasting question before we move on to the actual lecture? Start diving into functional programming. Okay, if not, then let's proceed and move forward. Oh, what was the answer? Over here, let me write it so that after the class, I'll post the annotated slides as well. This is called Hamming distance. And you can go to Wikipedia and it would have a good explanation on what it actually is doing. It has a lot of use in security world. Now let's dive into functional programming. The first thing that we need to talk about is the concept called expression. Whenever you compile a code, have you seen this term before, expression? In some error code? Yep, right. So it was this expression with some problem, like whatever the problem is on the error message, depending on what you are exactly doing on your code, right? Let me mute some of you because there was some background noise. And what are expressions? Expression is basically whatever you type in, right? Whatever you type in your program. Let's say you type in 10, right? The value 10. This expression evaluate to 10. And this expression would have an int as a type, right? So hopefully when you read the compiler message, at least with the error message, it hopefully is more clear now. Like, hey, I said this expression doesn't evaluate to an int, but the function requires an int. This is why you look at certain things you type in and you say, hey, the type mismatch. For example, you are trying to put a string and use it as an int. Compiler would give you an error. It's like, I don't know what you're trying to do here. I don't even know how to guess what should I do here. I have no idea, right? That's why it's an expression doesn't, and there's an expression plus some error message. If you write in 12 plus 13, it's an expression that evaluates to 25, right? 25, because you add the two numbers together. The type is an int. Basically binding is the process of naming your expression. In Scala, so if you install Scala, you can bind an expression to a value, right? I mean, bind expression to a name. So this is expression. This is the name, right? This gives the name called number that has a type int, right? And the value of number evaluate to 10. And you can combine multiple expressions together to form a different expression. You write in number multiplied by 10. It basically means it's an expression that would perform number, but take whatever number is, which right now has a type int, multiplied by 10. Yes. So the name, we in the way we design a language, we call this thing name, right? In C, the analogy in C is like the variable, but name is a little bit broader, right? It's broader because let's say you do A plus B, right? A plus B is an expression. The variable A and the variable B is getting added together, and you can name this, right? You can name this expression as well. You can name a function. You can name a function plus something. You can name the I guess object. So is it a variable? So it's kind of like a little bit broader because it applies to the concept of creating a new programming language. Basically, the process of binding the expression to certain, I guess, variable, if you want to say it, to the name is called binding the name to expression. And it doesn't always have to have a type, right? You can write in 3 multiplied by hello, which have no, but this doesn't evaluate to a type unless you overwrite how this multiply works, right? You can actually override how multiply works and say, if the left side is an int, the right side is a string, this is what you do, right? This is possible, but it doesn't always evaluate or have a type. A type means that it's a type that the data represent. 10 is an integer, 10.1 is a floating point, hello is a string or character. And as I said earlier, you can name the expression. This is the process of define the name for the expression, right? You can think of this as a math function. Basically, you can say def cube, right? Cube would do x multiplied by x multiplied by x. And declare the sum of the cube, right? By having the input x and y as a double. And then you would define it such that you call cube, the function cube earlier, you define it twice, right? With x and y. That is how you can keep defining things and binding different name to different math function. Hopefully it is obvious so far. Any questions? All right. So when you want to evaluate and figure out, okay, what is the value of my expression, right? This is called one way you can do it is called using the substitution model. When you want to evaluate the wait, let me pull up the chat. For some reason, my desktop chat and the laptop chat is. Yeah, so that's a great question. The question is, if you look at the earlier code example here, x colon double, it means that I'm gonna declare the variable x, the name x. The x has the type double. The type follow the colon sign. That's a syntax in Scala. Basically, whenever you're writing in Scala, you would then declare the type by using the colon. It tells the compiler that, hey, whatever name this is, it would have this type. If you actually use a different type and put it in, Scala would basically yell at you, say, hey, that's the wrong type. You declare it to be a double, but then somehow you put in a string. Error, I'm not going to compile this for you because I don't know what to do with it, right? Most of the time when you see compile error, most of the time when you see warning, it's because the compiler literally have no idea what you want to do with this, right? That's why it gives the warning, because it's like, I don't know what you want to do here, and I cannot guess because I have no idea what you want to do here. So please look at your code and double check it. So compile error and warning messages mean something. It always means something. It always means that the compiler is trying to guess what you try to do here. Please check if it's correct or not. So when you evaluate an expression, you can use this thing called substitution model. The way substitution model works is, let's go through an example. Let's say you have the definition, define a function f. It takes n as an input, n would take an int. But if you want to evaluate things like, let's say f of 2 plus 1, looks simple, right? Basically, it's 3 multiplied by 3. The substitution model would do this. You would first evaluate 2 plus 1. That evaluate to 3. Every time you see f as this expression, you replace it with, every time you see n as this expression, every time you see n here, you replace it with 3. So here, 2 plus 1 move to f of 3. You replace, this is what I mean. You replace n with 3. So it's n multiplied by n. You replace n with 3. So it's 3 multiplied by 3. That becomes 9. And this is how you can evaluate and reach the actual value through the program. This is, again, if you look at this from the human point of view, this is super simple, right? But it gives the computer the rule book that say, okay, if this is what you see, do these steps, and eventually you have the results. It gives the computer an actual step-by-step, right? Step-by-step, what to do based on the expression it's seen, so that it can eventually reach a result. Right. Any questions about why should we care about the substitution model? Basically, it allows, right? It allows you to tell the to tell the computer what is the end result of your expression. And with the substitution model, the other thing I want to mention is termination, right? If everything is a function and you do substitution over and over and over and over again, most expression would probably evaluate eventually to a value, right? Some number, some string. The question is, does every expression reduce? Reduce means eventually evaluate to something. Basically, evaluate to a value in finite step. So that's my question. Now, discussion, answer, question with question, small questions. How many people say yes? And how many say no? So most expression actually evaluate. So that the answer is no, and I'll tell you how I can write an expression that doesn't evaluate in finite steps. most expression evaluate in finite steps. But if I do this as a def loop, which take a type of int, return the same thing, return the name. The name, think of it as this. I have a name that takes a type of int and I return my own. This is a totally valid declaration in Scala, right? But it never terminates because it doesn't take an input. It doesn't evaluate to anything. It tries to evaluate to itself, but itself is not declared as a value. So it doesn't actually terminate as a value, right? So with our substitution model, you replace loop with loop. And this go on indefinitely. Yay, right? So not every expression reduced to a value in finite steps. Right? In finite steps. Yes, this is basically infinite recursion. You call yourself and yourself have no answer what who you are. That gets rhetorical real quick, but yeah, you don't know what you are. You can't evaluate yourself to a value, right? You just keep calling and there's no answer. And that gets weirdly like dark. you don't evaluate to anything. So let's come up with a different evaluation strategy. Right? So far we use a substitution model. So let's experiment with a different strategy where we just pass, like let's say if you get f of 2 plus 1, you just pass in 2 plus 1. You replace n. Instead of replace n with 3, you replace n with 2 plus 1. You're not going to evaluate 2 plus 1 yet. You're going to keep passing things in until everything becomes a number, and then you get 9. Right? Even though you notice this give you the same results. And why is that the case? If your computation has no side effects, we'll talk about side effects later. But let me give you some examples. Side effects are things like suddenly your code give you error or throw exception, right? If your code somehow throw exception in the middle, the first way and the second way, the evaluation strategy would give you different results because one of them would have an exception, the other one might not. But eventually they would yield the same results. So this means that you can have a different function calling styles, and we would define it as two styles in total. Call by value, you first reduce and then you substitute, or call by name, where you substitute first and then reduce. And both strategy evaluate to the same final value. And here's a theorem, right? Both evaluation terminate. That's what we assume. If call by value, okay, so first of all, if you have just pure functions, both of them would terminate. You know what the value is. If you do a call by value and the call by value terminate, the call by name version will terminate as well. It's not true in the other direction. If you have a call by name and that terminate, it doesn't mean the call by value would terminate. Here's the example. This is like more detail, right? Call by value means every function argument is evaluated once. Call by name is you're gonna delay the evaluation. You do the f2 plus 1 and keep the 2 plus 1 over and over and over. And then when it reaches the last line, you then replace everything into a number, right? 2 plus 1 will get added to 3, and then you have 2 plus 1 multiplied by 2 plus 1, 3 multiplied by 3, and that becomes 9. Call by value would kind of like slowly evaluate while you are going through the function. Scalar is by default call by value, but you can invoke call by name by annotating input parameter with a type. We'll talk about this later, so don't worry about it right now. We'll talk about it later when you have Scala installed and when you have some sample code about what do I mean by you have x colon arrow sign int rather than x colon int, right? Basically, when you have this arrow sign, it means forcing to be called by name. But let's play around with it a little bit, right? So let's consider the same function. It takes x and y as an integer. The first line is called by value. The second line is called by name. And I declare my loop. The same loop that we discussed earlier, right? This is your, I guess, quick homework. We can talk about it next week. Before we begin the class lecture, I'll have this slide again and you tell me what happened if you do this. You tell me what happened if I do the first method, the second method, the third method, and the fourth method in Scala. And you notice that some of these, well, it involves a loop, right? So this will not terminate. You see why it doesn't terminate for some of them, and why some of them might terminate. How can I know? Because the expression doesn't really involve y, right? You just return x, return the left, it return the left variable. So based on this, the call by value and the call by name version. So obviously 2 and 4 doesn't terminate, right? You put in a loop and you return a loop. So that function would return a loop. The left, the 1 and 3, one of them would terminate. And the mini homework is someone tell me which one. If no one does this, next time we come back the next lecture, someone will be typing this on their monitor and I'll ask the answer before we move on. But this is an example of like the difference between call by value and call by name. And some of them might terminate. Conditional, why do I have this bracket? And I can't erase it too. Okay, PowerPoint. What's wrong with PowerPoint? Okay, disregard this weird bracket. Somehow it's up here. Conditional expression. This is because Scala offer the if then else construct. So you can do if else statement, right? It tells which expression to do next. If this is true, do the one before the else. If this is false, do the else. Right? So example is this. Let's say you define an absolute function, right? Where if x is less than 0, you return negative of x, otherwise you return x. And magically this bracket is in the box. Okay. Using the construct, we can say that if e1, the expression right here, is true, you would then do e2, which is negative x. Otherwise, you do x, right? Return x. And this is how you can evaluate it to either e2 or e3. And here's an example, right? Let's evaluate absolute of negative 40 using the substitution model, right? Let's use the substitution model. If x is less or equal to 0, you have x, you have negative x or x here. And you then replace right here where x is actually negative 40. So you put negative 40 into here and into here. So the next line becomes if you have negative 40 is less than 0. Okay, so into here, so I forgot. Basically, if negative 40 is less than 0, which is true, right? Which is true, then you would then do this. But everything stay, right? Because you need to first evaluate this. This is the first thing you have to do, this part. It becomes true. When this becomes true, you just leave out this expression, negative of negative 40, which becomes 40. If you do absolute 5, the same step. You replace x with 5. over here, right? And then you have this, you're gonna evaluate to false, which means this thing go away, left with this. So you got 5. Any questions about this before we go to a more complex example? So let's define our friendly loop again. And define goof, which is x of int, right? You take x as an input. If x is less than 0, you return loop. Otherwise, you return 10. What happened if you run this versus this? Anyone want to take a guess on what happened? Which one will result in infinite loop? -1, right? Because it's true, so you return loop. When you return loop, it just go on forever. But goof of 1 will return 10, even though you have a loop in there. Why? Let's go through the substitution model, the friendly substitution model. What we have here is if 1 is less than 0, loop, this is E2, right? This is E1. Else, 10, this is E3. This is false, right? Loop, else, 10. This thing get rid of loop, so you return 10. That's why this would give you 10. This gives you loop. All right, any questions? Okay, so Boolean expression, true or false, right? You can reduce that. Basically, let's take 2 basic values, true and false. You evaluate this using normal logic operations. Not true is false. True and E is E. True or E is true. Not false is true. Simple. Hopefully you have no question, but if you have question, please ask now. So these are the 6 things that can help you when you evaluate something that involves infinite recursion or a loop. So what does the term def do? As I said, def in Scala. So this is going toward more like a Scala syntax. Whenever you type in def, it bind the name you just put in to the expression. So fundamentally, this is by name, right? This is called by name. The right-hand expression is not evaluated until you use it. E represent either true or false. You mean E here? E is expression. It can be 10, it can be 20, it can be hello, right? But if you use a logic operation like this, that's the result. Oh, okay, I got your question now. So this specific E, right? This specific E is Boolean. Yeah, Boolean. My bad. Now I understand your question. So E is a Boolean type. It can be true or false. I don't care. But true and something is that something. True or E is going to be true. All right. So let's go back to our slides. Fundamentally, def is like a by name thing. So the right hand expression is not evaluated until use. So if you want to use a by value, you use val. Instead of def, you say val like this. Yes, you can think of it this way, but both def and val are kind of like defined in other language. But def and val, the difference is which one is called by name, this which one is called by value. val will is called by value. Def is called by name. If you do val foo2 equals 11 plus 20, you just add 11 plus 20 into 31, put that into foo2. Def foo1 equal 11 plus 20, you delay that. You delay 11 plus 20, just leave it like that until you actually use foo1. Both of them kind of work like a define, depending on what define you're using in different languages. So I hope that addressed your question. It's kind of like odd. Is val a const? Not exactly, because you can have like you can do 11 plus f of n, which is a function. It's not a const because function can return different value, right? But whenever you can evaluate the right hand side, you would do it right away. So it's like not exactly a const. There's a concept of a const also in Scala, which is different from val. So does it answer your question? It's kind of like not exactly a const unless the right hand side is all constant. But if the right hand side is not constant, then yeah, it's not exactly const. You can use const in Scala. There's a different keyword for that. We will talk about it, I think, in the next 4 lecture, I think. Oh, I love PowerPoint, but circle stay every slide now. Let's see if we can erase this. Nope, I cannot. It's gone. So example, let's do some example. Let's suppose x and y are Boolean, and we want to simulate the AND and OR. And remember that they have short circuit where you have false and something is false by default, even though you have a loop in here, right? Even if it's a loop, false and loop would be false. So if you do this, x and y, which are both Boolean, we say we want to do an AND. This versus this. This is my second homework to you. Notice that one of them would be the call. This is called by name. This is called by value. Right? The arrow sign is called by value. Which one would return the short circuit version and what value? Right? So that's some exercise for you to do. You can have a different value of x. X can be true, x can be false, y can be true, y can be false. And then you try out what about if I put in the loop, right? A loop that takes a Boolean, a loop that takes Boolean. What if I do false and loop? What will you get? What if you do true or loop? What will you get? What if you do loop or false, loop or true? What will you get? This is a good exercise to kind of like fully understand these concepts. If you don't do this, I'm gonna again have this on the review before the class next week, and I'll ask you what happened. And let's do some nested function, because you can have function inside a function. We'll cover this more in detail, but here's some example of what like primer into this class. So actually one quick thing. The content we talk today will cover kind of like some of the things we're going to talk about the first half of the class. So this is kind of like a preview into what you are going to learn. Hopefully that can kind of answer your question about like, am I ready to take this class or should I wait as well, on top of my answer, which is like, okay, you're going to learn new language, a new way to write a program. So personally, I think it's never too early to do this. I think. But different people might have different opinion. I will respect your opinion for sure. So nested. Okay, sorry, I saw the chat. For val and def, they can use abstract types. Yeah, yes, they can be abstract type. They can bind. Basically, they can bind your name, def and val into any type. That's fine. Here's a nested function. You have a function inside the function. The one inside called square root. No, not square root. Use square, SQR. You multiply the two numbers together inside the function called sum of square. What happened here, because you see this bracket, right? It means that outside of this range, right? Outside of this range, SQR doesn't exist. If outside of this, someone called SQR is not known, is not defined. This is called nested function. The benefit of this is it helps with namespace pollution. You remember, right? Everything has a name. A name is bind to an expression. So how many expression that you can bind if I give you only 2 characters between A to Z? Let's say I want to name my variable a b, a c, a d, a e, a f, right? So you have 26 multiplied with 26, that's the number of variable I can bind. In this case, sometimes when you keep writing the program, sometimes you accidentally have a function or variable of the same name. Having this nested function reduces this pollution. And one thing to notice, in Scala, anything that right before the end of my bracket right here, the line before is a return value. By definition, you are returning that whatever expression that is, you're returning that expression. Sum of square would then evaluate to square x plus square y, which is this line. This is the return. The return value, right? And this bracket give you the new concept in programming language, which is called a block, right? A block is basically a block defined within this curly bracket. This is valid. You can have val number equal 10, number plus 1. If you do this, val num, yeah, I can write num. And then somehow close the bracket and say num plus 1. This is not valid because outside of this bracket, I don't know what num is. It's defined inside the bracket, but not the outside. But extend this idea, you can also do def, right? Def full bracket. Now you define this whole block. You bind this whole block to a name. You bind this whole expression block to full. So later on, if I type in full, what value will I get? 11, yes, correct. So you can use it later. You type in full, you get 11. Why? Because full is now named to number plus 1 and numbers inside this block is named to 10. So the whole expression full binds to the value, well, binds to this block and it evaluates. I want to be careful with my wording. It evaluates to 11. Which means that you have visibility, right? As I said earlier, things that define inside a block is only visible from inside the block. The definition inside the shadow things defined outside the block is not valid. So let's say this: if I do x equal 5, right, and then I have val results inside there, you have x, which is 6, and x plus 1. What will I see here? Can I do this through print? Promise you this is the last slides that are content of this class. Yes. x outside of this bracket is the old x. Let's call this x sub 1. This is x sub 1. This is x sub 2. This is basically print x sub 1. This is print x sub 2 plus 1, right? This is 5. This is 7. So you are going to get 5, 7. Correct? Thank you so much for replying to me. That's actually all I need from you guys. Basically, whenever I'm asking some question, please respond so that I know that someone's still here. And for those who want to watch the YouTube video later, yeah, feel free to. I'll post the video whenever it becomes available. Usually I'll do it during the weekend. Once I have the channel set up with the first video, I'm gonna post it there. So before we leave today, this is your kind of like in-class exercise before we move on to Discord. Make sure you have Scala installed. Please install it right now. The next week that we meet on Friday, I'm hoping that everyone has this install. It's on your in-class exercise one. And the only thing you do is put in this code. When you run it, it should print hello world. When you got the message, take a screenshot, submit it to your in-class exercise slots. And one thing I want to point out to you, Scala, similar to Python, it's a REPL. It has REPL support. REPL means that I can type in things line by line. Is repeat is actually stands for repeat, evaluate, print loop. You put a command in, evaluate, it prints the results, you loop to the next line that you want to type in. But you can write the whole program inside without using REPL as well. And yeah, as I said, expression can be entered directly into REPL. Extend app. So app is a library. So this is something that we're gonna cover what does library mean. But basically it means over here app inside the world of Scala, apps means that this is the program you want to run. And yeah, so let me answer the second question. So which is yes, just capture the screen and submit the picture for in-class exercise 1. The picture that said hello world. I want to make sure that you have this picture to make sure that you have IDE working. I think it had a better link to Java, but I have heard some success from your senior. I'll actually recommend check with whoever take OPL before. You can ask it on Discord as well on if they have a preferred IDE, because I've seen so many things. I'm not sure if it has its own IDE on the website. I think it kind of pair with Java, kind of like bundle. But I'm not sure. I haven't fully checked from the website. The one I use is a kind of like Linux based. That's pretty terminal-ish, and I use Vim for the IDE. I actually encourage people to use Vim if that's not too bad for you guys. But yeah, Vim is awesome. Or Emacs as well, but I'm the Vim guy. I still don't remember the Emacs command. Yeah, just capture a screenshot. Is there still afternoon session? I'll open the Discord, so I'll be online on Discord. You can feel free to come by, chat. If you want to talk about things outside of this class, feel free to. Things like, okay, what else can you? Yeah. Unless you want me to power through 2 more hours of lecture. Usually after this will be in-class exercise. No. So it won't be just a morning period. But the way I look at this is I am going to, because there are so many in-class exercise anyway, if it's 2 hours class, usually what happens, I finish in like 1 hour or 1 hour 30 minutes. The other hour or the other 30 minutes is like basically I'm going through the room physically and making sure everyone do the in-class exercise, so that they know how to code in Scala. It's a new language, so the exercise helped a lot. Because it's the first class, the exercise is make sure you have Scala installed. I would be on Discord right after this to make sure you have the yes, I miss classroom lessons too. Okay, but aren't you kind of like always playing games in the back of the room? Uh, oh yeah, I mean if that helps you focus, that's fine. Basically, because most of the time, I think you're catching up to the class, and after the class, you would always be in 1409 to like ask questions. Yes, it is the environment. I think a lot of people use IntelliJ actually, and you just need to install Scala compiler support in IntelliJ. Yeah, it seems like you guys are using IntelliJ. Maybe I should check it out. Like I'm too. I want to say this, but it's like when I took CS undergrad, it's kind of like migrate to Vim. I'm like those old days where the only thing you have is like Notepad++ and Vim. Will I be in MUIC on weekdays? I can try. Basically, I might drop by sometime. I would try to be honest, but the thing is, it's are you talking about like non-class time weekday, or like are you talking about class time weekday? Because Sky doesn't put me into an actual lecture room, non-class time, yeah, I can drop by. It's actually not that far from my where I am. If you guys doesn't know me or took classes with me yet, let me tell you who I am. Basically, I'm actually a part-time lecturer because I got a Thai scholarship when I was high school, and I just have to work at King Mongkut University of Technology in North Bangkok for like 20 years to serve my contract. So that's where I'm based off. But yeah, from there it's only like 30 minutes drive, I think. Yeah, so we'll have an online class for now. For non-class time, maybe if it's close to what teaches drama, there's no drama here. It's just a government contract. Uh, well, I mean, literally no drama here. I love where I'm working at. Like, I love my upper management. They're awesome. They give me a lot of freedom. That's why I can come here and teach, right? Uh, and I think the limited funding to like new researcher, if you want to have me tell you that, it's like it happened to everyone, everywhere. Um, But yeah, I'm at this thing called TTGS, Thai German graduate study. I primarily my department only teach master and PhD, and I love teaching at MUIC as well because it gives me access to like undergrad, uh, to actually feel like I'm teaching, right? To actually feel like I'm teaching, and I'll try to be on campus at MUIC maybe like bi-weekly, dropping by. Are you still hanging out at 1409? Or is there like different places you hang out? Ghost room? Oh, okay. Oh, so are you, is it open? So that's the thing. I'm not even sure if it's open or not. Oh, you're a freshman. Uh, I have heard for those folks who are in 1409 from like your younger folks that you look scary or you guys look depressed all the time. Yeah, maybe that's Vicky. Don't scare your junior student. Don't like put the stuffed animal on the power cord and hang him up too. I mean, I guess you can do that, but you have to let them know what actually happened. Uh, oh, it's still there? Okay, anyway, so yeah, I can drop by for sure. I wouldn't mind. I just need to check my schedule. The Yeah, I have time. And I agree that meeting someone, your student in person is effective. But at least I'll get to know the student better, right? I've seen many of you on like system skill last semester, but it's because it's online. It's like, oh, I know that name, I know that name, I know that name. I can pair the name with the personality. Yeah, and yeah, you should meet your senior. They might look like their life looks, or at least their face would look kind of miserable. Uh, oh, will system still be open? I think that depends on the demand. I think it's been open like alternative between 2 semester. So my guess is it might be open. There's also, from what I've heard from Ajahn Kanat, there is a plan to open up the class between, basically the range of the topic we're teaching is between system skill and OS architecture network. It's kind of like the introduction to like OS architecture and network. Because from system skill into the OS, nightmare. System skill into architecture, nightmare. And well, I mean, a lot of us have graduated from CMU. So that's how we were taught. So yeah, is the campus open and basically you guys are in a dormitory and in the university pretty much? Oh, okay. So it's open. I didn't realize that. Uh, yeah, it was kind of odd because I was sent an email. I was like, okay, do you want to do online or offline? And it's like, okay, I guess online. Then I don't know, but yeah. So then I have a question. Do you prefer in-person exam for like the whole, well, I guess I'll make the exam not to exceed 3 hours, or do you prefer take home campus exam? I believe, let me try to check this out. I believe I might be able to book a room to Sky because basically this class is not assigned a classroom. And then let me check with the policy, right? Let me check with the policy because yes, I agree. We need to make a poll. That I need to check with the policy whether if we do it in person, do I have to split your class into 2 sessions because of social distancing rule? That's actually the majority of the reason why I want to do online this semester because I think they tell me I can't do a full blown offline. Oh, you're not in the country. Okay, that's a problem. Then I think let's do take home. At least one of you cannot take the. No, don't get COVID. That's not good. Come on, it's a scary thing. You can die from that. And you think biology? Why why are you? No, you can study virus. You can study bioinformatics. Don't get COVID. It's a totally different thing. All right, so I mean, okay. So let me tell you one thing. That this is the end of today's lecture. It's kind of like a little bit faster than I planned it would be. So next time I'll have more material so that it cover like 2 hours and maybe like 15 minutes. Uh, oh, make sure you don't pass out through the 4 hours process. I promise. I'll keep making random jokes and like interject with like getting sidetracked while hopefully still making sure hopefully making sure you are still learning uh and have a bunch of exercise. Do you prefer, oh, when I get serious? I mean, no, I think I'm happy and kind in most cases until you see some exam that I make by mistake that are too hard. Oops. Yeah, I think sometimes, I mean, yeah, I'm still learning. This is my first year. I just finished my first year of teaching. So, so I still need to adjust my difficulty when I do the midterm and final, as a quick warning. But I'll try my best. I'll try my best and I'll curve. Just make sure you submit all your assignments. Yeah, good. So if you enjoy me getting sidetracked while making sure you can come back to the topic we're teaching, I'm happy getting sidetracked to make sure you're awake. And I like talking about story related to computer, right? Because my expertise is on the area of building computer, building the hardware. So I have a lot of things to tell, and one of the things that I find in Thailand in particular is we are pretty weak at hardware. Not a definitely not a lot of experts here. Definitely not a lot of professor who specialize in this. So hopefully I can kind of like shape this. Max Silicon. You mean the latest one? How much is that? Okay, now that I got super sidetracked, let me stop the recording so that I don't have the file that are like 100 something megabytes.